Balancing chemical equations is a fundamental idea in chemistry. Today, we'll balance the chemical equation. Al plus ZnCl2 equals Zn plus AlCl3. We'll go step by step to ensure the number of atoms for each element on both sides of the equation is the same. Later, we'll also identify the type of reaction this equation represents. Let's balance the equation using coefficients to adjust the quantity of each substance. Start by counting the atoms of each element on both sides of the equation. For aluminum, there is 1 atom on the left and 1 on the right. For chlorine, there are 2 atoms in the reactants and 3 atoms in the product. Zinc has 1 atom on each side. To balance the chlorine, we'll need to make sure the number of chlorine atoms is the same on both sides. We need to find the least common multiple of 2 and 3 to balance the chlorine atoms, which is 6. This suggests placing a coefficient of 3 in front of ZnCl2 and 2 in front of AlCl3. These coefficients adjust the number of chlorine atoms to 6 on each side. By doing so, the number of aluminum atoms on the right becomes 2. To match, we'll place a coefficient of 2 in front of Al on the left. Our balanced equation is 2Al plus 3ZnCl2 yields 3Zn plus 2AlCl3. Now, let's classify the reaction type. Al and Zn are displacing one another, indicating this is a single replacement reaction. In such reactions, one element swaps places with another in a compound. That wraps up how to balance the chemical equation. Al plus ZnCl2 equals Zn plus AlCl3 using least common multiples and identify it as a single replacement reaction. Balancing chemical equations ensures the law of conservation of mass is met, with equal numbers of each type of atom on both sides.